This is a video recording for chapter 5.2 on solving simultaneous linear equations using the graphical method. So let's do a quick recap first. We recall that all points on a linear graph, there are solutions. So for example, for the equation y equals to half x minus 1, we can plot a graph using this information by substituting values of x and the corresponding values of y. So for example, when x is equal to 0, y will be negative 1. So when x equals to 2, y is 0, so on and so forth. So this will result in a graph looking like this. So we've got a point of x equals 0, y equals to negative 1, this over here. When x is equal to 2, y is equal to 0, so on and so forth. So every single point on this graph, on this line, they will have x and y coordinates corresponding to this equation over here, and they will satisfy the equation. So that is what I mean by every single point on the graph is a solution. Okay, so one more example. For example, we have y equals to negative x plus 5. Again, we can be plotting the points out, x and y. So these are some of the values that we can have. 0, 5, 2, 3, 4, 1, 6, negative 1. So by plotting all these points down, okay, so over here we have 0, 5, 2, 3, 4 and 1, 6 and negative 1. So joining them up will result in a straight line. So in addition to all these coordinates, we've got actually more points on the graph. In fact, there are infinite points on the graph which serve as solutions to our equation. So that was our recap. Now, simultaneous equations. A system of linear equations with common variables, such as this is one equation, this is another equation. The common variables over here will be x and y. They are called simultaneous linear equations in two variables. There are two variables, they are x and y. So solving simultaneous equations means finding the values of both variables, which make the equations true simultaneously. So in this example, there is a certain value of x with a corresponding value of y that when substituted into both equations at the same time will make both of them true. So simultaneously simply means at the same time. So a solution will refer to the x and y values that satisfy both the equations in the system at the same time. Now this can be solved graphically by finding the coordinates of the point of intersection. Of the two linear graphs. Okay, so let's take a look at what could possibly happen. So this is the first case. Whenever I have two straight lines, the two lines will either intersect at one point, only one point for two straight lines, or the two lines, they are parallel to each other, or in the third case, they coincide, means they overlap. Exactly. Completely. So it is referring to the same line actually. Okay, so these are the three cases. One intersection point over here, this is where they intersect. In case number 2, they do not intersect at all because they are parallel. No matter how we extend the lines in both directions, they will not cut each other. And in case number 3, they overlap. So the two lines overlap each other. They are exactly the same. Okay, so what exactly do these mean? Now, in the first case, let's give these two graphs an equation. So for example, earlier on I used y equals to half x minus 1 and y equals to negative x plus 5. So let me use the same equations over here. This shall be my for this graph, this shall be y equals to half x minus 1. So obviously we know that this is negative 1, and this equation over here, let's have it to be y equals to negative x plus 5. So it's sloping down, gradient will be negative. And as we mentioned over here, these two graphs are made up of many points. In fact, there are infinite points, and we said that every single pair of coordinates, whether it's this, they will satisfy this equation of y equals half x minus 1. Similarly, for the second graph, all these ordered pairs, x and y values, they will satisfy y equals to negative x plus 5. Now if we put both graphs on the same x and y axis, this is what we are going to obtain. So here we have both of them on the same axis. Keeping in mind that all of these points are solutions to the individual graphs. Now, there is one certain point over here where the x value corresponds to the y value for both of these graphs, because this green point lies on my equation y equals to half x minus 1. At the same time, it lies on the equation y equals to negative x plus 5. So our job now is to find out what are these coordinates over here. Once we have them, we will be able to, it is considered as having solved the simultaneous equations. Okay, so in summary, is there an ordered pair that exists on both graphs? Okay, this ordered pair simply means a point. Is there a point that exists on both graphs at the same time? Okay, at the same time. If yes, then that ordered pair is the solution to the simultaneous equation. Okay. Now this is the question we're going to be asking ourselves for case number 2 also. Case number 2. These two lines, they are parallel to each other. How do we know that they are parallel to each other? We consider their gradient. Okay, so here we have two equations, equation number 1 and equation number 2. To determine whether they have the same gradient, we would like to put them in the form of y equals to mx plus c. So from equation 1, we have 4y equals to negative 3x plus 12. So y equals to negative 3 over 4x plus 3. So the gradient over here, we know that it is negative 3 over 4. So from equation 2, we've got 8y equals to negative 6x plus 9. So y equals to negative 3 over 4x plus 9 over 8. Gradient also equals to negative 3 over 4. Now since these two lines have the same gradient, they are parallel. Therefore, they cannot intersect each other. So is there an ordered pair that exists on both graphs at the same time? No, there isn't any point that exists on both graphs at the same time. Okay, therefore there is no solution. Since both graphs have the same gradient, they are parallel, and do not intersect. Therefore, there is no solution. Okay, now for case number 3, the two lines coincide. They overlap each other completely. That means that they are the same line. Okay, so here we have equation number 1 and equation number 2. Are they actually the same line? Let's look closely at equation 1 and equation number 2. Okay, they seem to be similar. So from equation 1, if we divide by 2 throughout, this is what I'm going to obtain. 4x divided by 2, we get 2x. And then we have plus 2y divided by 2, you get y. 10 divided by 2, you get 5, which is the same as equation number 2. So this is the same as equation 2. So since both lines coincide, there are infinite solutions. Why infinite? Because this is a solution, this is also a solution, this is a solution. All these are solutions that exist on both graphs at the same time. So let's try some of these examples. On the next page, we've got 12x plus 3y equals to 4. That is my equation number 1. And this is equation number 2. We are supposed to determine whether they have no solution or infinite set of solutions. No solutions means parallel lines. Okay, it means we want to find a gradient. Infinite set of solutions mean same line, they coincide. So that is what we are trying to determine now. Let us put everything into y equals to mx plus c, because from y equals to mx plus c, we can tell whether the gradients are the same. We can also tell whether the two graphs are actually the same as well. So from equation number 1, we've got 3y equals to negative 12x plus 4. So y equals to negative 4x plus 4 over 3. From equation number 2, we have y equals to negative 4x plus 1. So now we compare both gradients. Hey, they are the same, which tells us that they are parallel. Then, since these two graphs, these two equations are different, how do we know they are different? Because the y-intercept, they are different. Therefore, these two graphs, they do not coincide. They are parallel. So over here, for part A, answer, no solution. Because 1 and 2 are parallel. Now for part B, again we want to put it into y equals mx plus c. So equation 1 and equation number 2, we name them. From equation number 1, we've got 6y equals to 2x plus 2. Therefore we get y equals to 1/3 x plus 1/3. This is from equation number 1. And from equation number 2, we've got 3y equals to x plus 1. Dividing by 3, we get y equals to 1/3 x plus 1/3. And we see that, hey, these two graphs are the same. These two equations are the same. Meaning equation 1 is the same as equation number 2. Which tells us that, for part B, the two graphs, they coincide. So we will have infinite solution. Since equation number 1 and equation number 2 are the same. Okay, do part D and E by yourself.